Computer science students, I've decided to try and demonstrate one of the concepts with if statements that I haven't talked about in class using a video. So we're going to see how well this goes. So I've got BlueJ going here, and I've got a runner and a class. So what I'm trying to demonstrate here is something called an if-else ladder, which is where if statements have else ifs attached to them, and you go through a series of questions that can result in only one answer. So the example I decided to do here is a class that you give it a number grade and it will convert it automatically into a letter grade, and there are going to be some constraints. But let's just talk really quickly about my class. So I call the class letter grade. It's got two fields, two of the instance variables, which is another word for field. One's an integer, that's the number grade, which would be only between 0 and 100 inclusive, but I'll come back to that. And once I have a number between 0 and 100, I'm going to convert it to a letter grade. So this is what we'll start with, num grade, inside the constructor, and we're actually going to convert it into a letter grade, which will be a character. And the choices are only going to be A, B, C, D, or F. Okay. So I've only written one constructor for this particular class because it only works if you give it a number to represent the starting point, right? So that's why I consume as input an integer, and then I'm calling my the set method, right? So this is a very common pattern we've been following, and you'll notice down here on lines 12 through 15, there's my set method. Consumes this, sets the variable equal to the parameter. Variable on the left, parameter on the right. Variable is the one that's declared up here, an instance variable, parameter is this guy. Notice this second line though right here. So in my constructor, as soon as I set the number grade, the very next thing I do is call this other method I've written here called getLetterGrade. If I've written it correctly, this thing is going to spit out a character into my variable letter grade that represents the correct letter. So if this were, say, a 93, and when I call get letter grade, 93 better come out as an A. That sort of thing. Okay, so let's look at this get letter grade method. Notice it's public because all methods are public. It returns a character, hence the char right there. And it doesn't consume any input because that variable, the number grade, is actually set inside the constructor. So I already know that variable. I don't need it. Okay, so you'll notice that I've got something declared at the top, res, for result, you know how I am. And then at the bottom I'm returning that, right? So this pattern is based on what we've been doing so far. You have something, you make an assumption, and then you write your if statement and you return whatever fits the return type, in this case a character. I wanted to demonstrate though that this if-else ladder lets you take care of all the possibilities. So I've actually set up at the top my result. I've set it to something that should be invalid for a letter grade, E. So when I go to my runner and I test it out, if I ever see an E as the letter grade, I know I've done it wrong. Okay? So I'm only doing that here because I'm going to demonstrate how the else-if ladder that I've made here takes care of all the possibilities. Okay, so let's look. We've got an if statement, and then an else if, and another else if, and another else if, and an else. So the way this works, I've got one question that I'm asking, and if the answer to this is false, then and only then does it go to line 25 and ask this question. And if that one's false, it goes to this one. And if that one's false, it goes to this one. And if that one's false, it automatically goes to this default option down here. So I've got 1, 2, 3, 4, 5 possibilities, but because of the way this thing is built, you can only end up at one of these places. So if the first one is true, then it actually skips all the rest of the else's and the ifs and the last thing. It skips everything because this one was true and would go down to this line of code on line 42. So whichever spot in an else-if ladder is the correct one, that's where the whole thing ends. And it's, instead of having to nest them together, you can build them into this kind of structure. This is yet another way to do else statements connected with ifs. Notice that I've put curly braces after each one of these else's, even though I don't really need them because I only have one line of code, but I feel like it's a little bit more structured this way. So if we look at each one of the statements, so I've got here, if num grade is greater than or equal to 90, well, that's supposed to be an A. So notice that I don't have I don't have an upper bound on this, but I'll come back to why I don't need to in my runner, because in my runner I've done something to make sure the grade can actually never be greater than 100. But even if it is, that still should be an A. So the result should be the character A if you have a 90 or above. So notice that when I get to this else if right here, I already know for a fact the grade has to be less than 90, or else I would not have ended up here. The only way to get to line 25 is if the grade is less than 90. So I don't have to check the upper bound for the variable because I know it's less than 90. So all I need to know is what the bottom bound is, right? So if num grade is greater than or equal to 80, then I know that's a B. Else, if the grade is greater than or equal to 75, I know that's a C. Else, if the grade is greater than a 70, it's a D. And if I've made it through each one of these, if it ended up with line 23, then it was greater than or equal to 90. If it ended at line 27, it was less than 90 but greater than or equal to 80. If it ended up here at line 31, then I know it had to be less than 80 but greater than or equal to 75. But if it ended up at line 35, I know it had to be less than 75 but greater than or equal to 70. And if it made it through each one of these and none of them were ever true, then I know for a fact, because of the way I've built this, that that has to be less than a 70. And for the purposes of this lab, or the purposes of our data here, that means it's an F. So notice the kind of constraints you have to have in order for this to work. You need to know all of your the data ranges. If it's a number, you have to know precisely what each and every option is for an if-else ladder to work. So this would work if you have a variety of possibilities and you know exactly what would end up at which possibility. If that's not, if the problem you're dealt doesn't have a very specific set of options like this, you really can't use an else-if ladder. You'll have to use some other kind of algorithm. So it really depends on what your data is before you know whether or not this is even a valid way to solve a problem. But for something like grades, or anywhere where you're having to break down the result based on some input data, some ranges of numbers, or some other kind of constraints, you know that there will be a certain number of possibilities, then this would work. And we'll see some other examples of this as we go through the year. An if-else ladder really is designed so that you can ask one question, and if the answer to that question is true, you're done. If not, you keep going with more questions until you get to the one possibility that does work. So the last thing I want to say about this is make sure when you're writing an else-if ladder, you usually, I can't think of a circumstance where you wouldn't, you usually want an else at the bottom, a sort of a catch-all, kind of a, if I got here, then everything else must not have been true. And that's also why, by the way, I use at the top a result that I know should never work. That way when I test my program, if I ever see the letter E, then I know my else-if ladder failed, and I can come straight back here and look for a flaw in my algorithm. Okay, so we're actually doing multiple things. Not only did instead of making assumption at the top, we actually set it to a completely invalid answer so that if we messed up, we'll be able to quickly find out where in our if-else ladder we failed. Okay, so let's look at the toString. This isn't terribly complicated. This is very similar to what we've been doing in all the other labs. All I really am doing here with my toString is saying what the number grade is, and then the string is A, and what the letter grade. So 85 is A, B. Yes, I realize the grammar's bad. Go with it. And just a reminder, the toString is the method that's called anytime I print an object from this class. And every single object in Java has a toString. Most of the time we want to rewrite the toString though, because the one that comes for free with Java just prints out its hexadecimal address, which really isn't that useful. So this is the same pattern we've been following though. So it is slightly more complicated, but we've got a constructor, a set method. I've written a get method here that does the logic for us, this if-else ladder. But we could have written this in a lot of different ways. I just chose to make it a get method. And then there's my my toString method, which doesn't do anything but print it out. So let's look at the runner real quick, because I got something I want to show you there. So I made a scanner, and then I prompted the user for a number grade. Notice that I'm using these square brackets here. Hopefully they understand, whoever runs my program will understand that that means from 0 to 100 inclusive. If I feel like that's not going to work, I might have to make it a little bit more clear. But let's assume for now that the person reading this green text is going to realize that I mean the only valid grades are from 0 to 100. And then I grab that number. Now look at this if-else statement I've written here. I'm trying to show you one of the options you can do with Boolean operators. So let's say that the user types in something less than 0 or greater than 100. I don't want that data. That's not going to work for me. I've written this so that a letter grade can only be in the range from 0 to 100. So that's what this if statement does. This one says if the number grade was greater than 100, I want to print this statement, or, and that's what the two vertical lines, the two pipes, or if the number grade was less than 100, I want to print this statement. So for the purposes of this particular data set, anything greater than 100 or less than a 0, I don't want to see it. It must not be valid. I'm going to have the user actually rerun the program and enter valid data. So the only way I'll get down to this else statement here, lines 17 through 21, is if what they gave me is good data. So if it's between 0 and 100 inclusive, awesome. That means it goes down to the else, and I'll run the constructor and then I print it out. And just by running the constructor, I'm calling that method getLetterGrade. So it does all of the work just by this one line of code, and then when I print it out, that information's already been figured out. Okay, so this OR statement right here is the least restrictive kind of Boolean operator. There are two other ones, there's an and there's a not. With the OR, if either one of these conditions is true, then I want to end up here. So look at the way I've written this. I'm considering it an error if the data is any of the numbers greater than 100 or any of the numbers less than 0. So I made that my least restrictive here really works because I'm saying I'm only interested in data in the range from 0 to 100. Anything else I'm calling bad. And I gave them an output message which is hopefully useful. Enter a number between 0 and 100. I didn't call them dumb. I didn't make fun of their family. I didn't tell them that they shouldn't be running my program, the kind of things people typically do when they're learning how to program. I gave them an error message or an output message that tells them what they've done wrong. So let's see if this one works. I probably should have tested it, but okay, here we go. Well, first of all, let's test it with bad data. So I'm going to enter 101. No, let's enter 9,001, so it's well over 9,000. Good. It actually stopped running and it told me enter a number between 0 and 100. So now I have to run it again because I didn't follow instructions. So I'm like, oh, well, let's try this, Mr. Smarty. I try -90. Again, it gives me an output message that tells me I did it wrong. So let's try one we know will work. Let's try 89. Oh, 89's a B. I know a lot of you have never seen that before, but there you go. Let's try it one more time with one that should be a valid chunk of data, but an F. 54 is an F. Okay, well, I haven't fully tested this, and I don't have all the test cases I typically implore for you to write, but for the purposes of this demonstration, that works well enough. We're about to learn about loops, where I could actually take this algorithm and run it multiple times inside of a loop. That'll just have to wait. The only other thing I wanted to point out is I can, besides using the OR, there's also something called the AND. And I could, if I wanted, here, I've gone back to my actual class, back to letter grade, back to get letter grade, back to my if-else ladder. If for some reason you're not confident that you've covered all the possibilities, you can actually add an AND statement here. Now, ANDs are more restrictive. So if num grade is less than or equal to 100, AND. So here I am, the same kind of rules I was enforcing in my if statement in the runner, I'm actually enforcing it here too. So the num grade has to be less than or equal to 100 and greater than or equal to 90. So this one's more restrictive. Now I'm specifically saying if the number's not this to this inclusive, then don't do this, go down to the next step. So for this pattern to follow, I would probably add ands to each and every one of them, but I think that's probably okay for this demonstration. Let me say it one more time. The AND statement is the most restrictive. Both Boolean statements have to be true for the statement to result in a true, and the OR statement is the least restrictive. Either of them can be true and you still get a true. So true or true results in true, but if one of these is false, I still get a true out of that. The AND, they both have to work. I'll save not for another time, but it's coming up pretty soon too. All right, I'm going to take these two files and put them on the chapter 6 notes page so you can, if you really want to, go back and run them later, or take my code and alter it. All right, hopefully that'll answer questions related to if-else ladders.